Up next, Frank Bauer, the ARIS NA Executive Director with the Amateur Radio Spectrum Use in the Lunar Environment. So please welcome Frank Bauer.
Thank you, Zach. Let me just say, I'm Frank Bauer. I didn't put my call sign on here, which I normally do. It's KA3HDO. I think everybody knows me, but you'll get to know me over time, I'm sure.
Your reputation precedes.
That is very true, Barry. My reputation does precede me. So I'm going to, this talk, I've kind of felt this was a good time to have a talk on, on radio spectrum in the lunar environment. I'm a little concerned, I will say, because I'm starting to see some things happening. It's great to see things happening, but I want to make sure that we are good stewards of the amateur radio frequencies as we try our best to be. I mean, we do know that there's a World Radio Conference coming up. One of the agenda items is on our spectrum, the 1300 megahertz spectrum concerns. And some of that has to do with the fact of people knowing what's going on in the world and, you know, how to protect our radio frequency spectrum. I heard George Presley just the other day. We were down talking to him, and he gave the talk to our one of our new director of education in ARIS, and, you know, passionately telling everybody how important it is for us to protect our microwave bands. And I totally agree. All of our bands that we have are important. And so I think it's important we talk about this now and start getting everyone, and, you know, this is in the United States discussion with AMSAT North America, but this really needs to be had across the world to make sure that when people are building things in the lunar environment, we operate on the frequencies that are out there for us. So just as a, and let me just say how this all came up, you know, it has to do with the fact that these individuals are starting to build satellites, and this past week, and it's actually been several months, I've been working, you know, my day job, most of it is ARIS, but I do support NASA on a part-time basis, and I support them on lunar position navigation, position navigation timing, but mainly lunar activities now. This is an offshoot of what we, AMSAT, did on AO40, where we actually showed you could use GPS above the constellation. We're now using GPS halfway to the moon, and we're talking about utilizing it in a lunar environment. So, so that's part of the position navigation and timing activity, but there's a lot of other aspects of it. And part of it, of course, has to do with frequency coordination. So the actual person that, we had a UN meeting this past week. It's called the International Committee on GNSS. And we had the person that handles frequency coordination give a presentation at that meeting. So what I want to tell you is that that person, actually, a number of the charts I have in here are from the person that runs the Lunar and Martian Spectrum Group as part of the Space Frequency Coordination Group. And I'll explain those terms in just a minute. But this basically, this chart shows the lunar landscape in just the next couple of years. And each one of these names on here are missions that are coming up. Some that you're very familiar with, the Artemis program. You know, with Artemis 1, that got launched this year, I should say. No, I'm sorry, last year. And then Artemis 2 coming up next year, and Artemis 3 later and beyond. Yeah, a number of you are familiar with the fact that AMSAT and ARIS have been working on the Lunar Gateway activities in a program called AREX, or Amateur Radio Experimentation. But there's a lot of commercial and space agency activities going on. There's you know, several dozen, as you can see here, several dozen missions being planned. Some of them are commercial, the CLIPS landers, the commercial landers that are going to be going to the surface of the moon. And one of them actually in next year is called Blue Ghost, which is being done by Firefly, and we have a lunar experiment on there, similar to what we did on for AMSAT Oscar 40. We're doing the same thing to fly around the moon and understand how well that will, how well GNSS can be received in and around the lunar environment and on the surface. So there's a lot of missions, and people are trying to get on those missions, including AMSAT and ARIS. And I know, and let me just say, AMSAT North America and ARIS are working on things, but there are people all around the world that are working on things. I've had a high school student that wanted to build a satellite, or a voice repeater and put it on the surface of the moon, and he wanted to do it on 2 meters. So let me just say that, and we'll talk about frequency spectrum in a few minutes. So the challenge, one of the biggest challenges we have here is there's a big deal with the radio astronomy community that when you're on the backside of the moon, you don't have any of the Earth signals anymore. And this is an opportunity of a lifetime of, humanity to be able to really utilize the backside of the moon and understand. I mean, we're all radio frequency folks. We always are interested in discovering things, and the radio astronomers want to discover things along with that. And so it gets back to similar to the national parks, how do you protect and preserve the opportunity to do that when actually the radio astronomers need to get their data out, so they need RF transmitters to be able to get their information out, and but at the same time to protect the opportunity. So basically what's being developed is a set of standards that can be applied to users and how we can operate in and around the moon. And I will tell you, this is a pretty, we all know how passionate people are on radio spectrum. This is another area, and we even heard it, I will tell you, at this UN meeting that I attended all this past week. So the ITU has defined an area called the shielded zone of the moon, and the way this is basically the definition of it, and they want to keep a very low noise environment for the observations of radio astronomy. The question is, what can we do, especially if you're an orbiter on the moon? If you land on the surface of the moon on the side that is opposite of the far side, in other words, the near side of the moon, and I think everybody knows that the moon is basically in a gravity gradient stabilized orbit, so basically the one side of the moon's always pointed to the Earth, and the other side is not. And so it's the side that's not. There is no, even Pink Floyd says on their album, there is no dark side of the moon, okay? So there is no dark side of the moon. It's the far side of the moon. And so shielding the far side of the moon from radio spectrum is important. But one of the things that's coming up, and you see the highlight at the bottom, is that the spectrum above 2 gigahertz is reserved, the spectrum below 2 gigahertz is reserved for radio astronomy. But they have interests in other areas too, and this has been a very complex dance, I'll say, between the organizations that are trying to utilize this spectrum and the radio astronomers. So this is an ongoing thing, and we all need to be sensitive to this and understand that some of this stuff might change. You notice at the bottom too that actually these charts were actually used by the folks for the meeting that I was talking about at the UN. So I'm giving full credit to the NASA. It's basically Kathy. Well, Lou knows this. Kathy Sham is the individual that coordinates a lot of this stuff for NASA, and she's actually the chair of the Lunar Martian Spectrum group. So the way they do this is through a thing called the ICG, and it's an organization that was developed similar to the ITU. That's an organization of the civil space agencies. When we started talking, and some of those that were involved in the ERICS activities early on, one of the first things we got told about flying on Lunar Gateway is have you been to the Space Frequency Coordination Group, and are your frequencies coordinated? And it's like, oh boy, this is a big shock. I don't even know what a Space Frequency Coordination Group is, let alone, how we coordinate with them. But then I found out that the person we'd been working with for 30 plus years on SAREX and ARIS was actually the same person that was from NASA that was doing some of this stuff. So basically, they are trying to work with the radio astronomers and try to, develop the plans, the policies, and things like that to be able to, and with the ITU. And literally, they've been, Kathy was at the ITU meetings, and then in our UN meeting, at pretty much almost the same time, because they're preparing for the World Radio Conference. And then there's other liaison organizations that are involved. There's a lot, these 4-letter and 5-letter organizations. Well, I think a lot of people know what IEEE is, but some of these other things, IOAG is basically an operations group within the space agencies, and things and CCSDS, I think a number of you know what that is. It basically, the Space Frequency Coordination Group is working with all of these groups to try to coordinate the frequencies and to make sure that radio astronomy is together. So there's a subset of the Space Frequency Coordination Group. It's been engaged for many, many years now, but for about 18 years, 17, 18 years now, the Lunar Martian Spectrum Group has been engaged, and basically that handles both Lunar and Mars, as you'd expect. So, this kind of shows, and let me just say, the amateur radio frequencies really aren't on this, but this shows the complexity of everything, starting with, lunar to Mars, the lunar to Earth and Earth to lunar activities, and what you would do on the surface, because, they're talking about things similar to a 5G type network on the surface of the moon, what could be done, what can't be done, and but basically these are all the frequencies that have been worked over time, and the big red one is optical. That's going to be the trunk line between Earth and the moon. Okay. And depending on what they're doing, whether it's lunar orbit, lunar surface, then we have these issues where NASA and other space agencies have been using frequencies for things like the spacesuits at 400 megahertz. And how do you handle that? Search and rescue right now is the primary frequencies at 406. Well, that's below 2 gigahertz. So how do you coordinate that? And they're working on frequencies associated with that. Some of them have been worked. Some of them are under study. And like I said, at least one of the frequencies for lunar position navigation and timing is in the C-band area, 5 gigahertz, and that's a contentious area too to talk about for various reasons, including wireless, the wireless community in the world, the wireless lobby, I would call it. So, bottom line is, what we tried to do was to look at the amateur satellite allocations that we have and work with the Space Frequency Coordination Group. And I'm going to start at the bottom because that's the part I want to focus on first. The other stuff I think everybody knows. When you talk about above 2 gigahertz, things are better. But I put the 70 centimeter and the 2 meter frequencies in red because really the only way we can utilize those is for contingency operations. And let me explain what that means. And I'm going to use the context of the Lunar Gateway as an example. I'll talk about ARIS and SAREX. SAREX and ARIS over the years have had the, I'll say, opportunity to utilize amateur radio how it's in one facet of what it's intended when all else fails to be able to support contingency communication. and we have been called up on and utilized on Space Shuttle, as Lou McFadden knows. We were called up on Space Station at one point. And there's been some incidents, you all know, even on Space Station, where there's been some problems. So it's a lot easier, you know, when you're talking about Lunar, it's a lot easier if there's a problem to utilize the lower frequency bands from the perspective of using a whip as compared to a highly gained antenna if the vehicle is not in the orientation you want it to be in, and to utilize modes like FT8 or something like that. I'm using that as an example, but modes that we could send messages back and forth to the crew and be able to communicate with that. So basically the 2 meter and 70 centimeter band would be utilized for contingency communications, or as it applies in the shielded zone of the moon, okay? Which means that if you didn't turn the transmitter on until you landed on the surface of the moon and you're on the near side of the moon, you could utilize 2 meters and 70 centimeters, okay? But you would have to show that you would not be utilizing it, you know, in that shielded zone of the moon. Okay, so I put that in red so you're all aware of that. The other things are very similar to what we do now. In other words, I'm using, you know, QO100 as an example. We're using X-band basically for downlink, and S-band for uplink for QO100. We also have put C-band in here as a capability. So the C-band and the S-band would be for uplink frequencies to the moon, and then X-band would be downlink. Okay, and I can come back to this and again, but basically this is the crux of what I wanted to bring up, is that we need to. And so I've seen a number of. There's already been a couple amateur radio satellites that have flown that have used 70 centimeters. I think we're going to be good stewards of the frequencies. I think we're going to need to try to move into microwave and do those things in the future. We can't use it on the backside of the moon. Right now, there are no, as we speak right now, there are no stations set up to do radio astronomy on the backside of the moon, but China has already flown a vehicle and landed on the backside of the moon. We are getting very close to starting to do things with observations on the backside of the moon. So we can't, you know, and we know it takes satellites a while to get there, and you know, to be able to turn your radio on and off at the right time if you're in a lunar orbit is going to be tough. So I really feel very strongly that we need to prevent utilizing our 70 centimeter and 2 meter bands for those types of operations, except for the thing I talked about, which I'll go back to that student that wanted to put a repeater on the surface of the moon. Well, if you do exactly what I described, which is you don't turn the thing on till you land and it's on the near side of the moon, that's doable, okay? So I just wanted to, my closing slide was just to show you what we've been planning relative to the ARIX, or the amateur radio exploration activity, you know, for Lunar Gateway, is using X-band for downlink capability and C and S-band for uplink capability. And on the right side there, you can see 70 centimeter in there for contingency comm. Okay? And that's all I have. So any questions or comments? Yes, Nick. Hold on.
What size antennas is it going to take to hear your station?
Oh, on the ground?
Yeah.
Well, that's a function of how much power we can do, okay? So, you know, Kent has been working with us on the ARIX activity, and he's come up with some gained antennas on the vehicle. You know, trying to put a lot of microwave out is a challenge, more from a safety perspective of the crew and us making sure we don't cause a problem there on X-band. But you know, what we were taught, we have different scenarios that we could fly. Some of them would use big dishes. Some of them would use dishes on the order of about, you know, a meter, basically 2-meter dishes. Okay.
Got it.
Okay. So part of it can be like, as you see on the right there, you know, we could use big radio dishes like Bochum or Goonhilly or Gavert for things like if we need to do emergency comm or as a telebridge station. As we learn more, as we find out how much power we can utilize and how much power we can pipe out of whatever we're flying, we'll define what size dish we would use. Is there another question? Yep.
Frank, you sort of reflected on it already, but what is the status of Lunar Gateway and the amateur radio involvement with it? Can you give us a quick summary of where things stand?
Yeah. All right. So I'll go back to that one chart, and I got to find it. It's like this is an eye chart. I understand that, but if you look at, let me see if I can do it here. 2027. See here. 2027 is when Gateway becomes our operational. Okay. The first they went through a process, and we were in the process of the first payloads they fly, and they were very limited. Actually, they didn't even have their interface documents done. They were very limited in what they could do, and they basically ended up selecting 2 payloads, which are radiation and ionospheric measurement, space weather type payloads, primarily because it affects human factors. You know, basically the astronauts and cosmonauts that would be flying to the moon area. So they started with that. They've been working through, because actually one of my jobs is to be in the Gateway and the Artemis meetings once a month. They're gotten very mature with their interface documents, and they're starting to come out with requests. So we're getting closer to this. They are still very interested in us. They haven't thrown us away. We have to keep, you know, it's like business development. You got to keep asking and talking and things like that. So that's what we're doing. I will say that I will say this, and this is for the whole community, and you know, this is something that we need to think about. There are opportunities on Artemis flights for orbiters, and so if you all really, I mean, but the problem is, and it was talked about yesterday, we need propulsion on these systems. So you know, golf is a start, but we need to get it to the point where we have some propulsion on them, on those vehicles too. So there's that, and then there's Gateway. So we're trying to look at all, and I'll say both ARIS and AMSAT are looking at these things together, because you notice the pictures, all of these charts have both AMSAT and ARIS on there. We need to work together on this if we're going to make this happen. And I think, you know, we're still out there for it. And for everyone's understanding, our best opportunity is for us to be on the logistics modules. The logistics modules come up. They spend it's about 6 months on at the Gateway, and then go away. But what we'd like to do, and one of the things we were talking about, is we could fly an antenna system that would be on each one of the logistics modules and have our hardware system available, that we could pull it away from the logistics module, keep it inside Gateway, and then integrate it back when the next logistics module is. So we're not spending all the money on the radio systems every time, but the antennas, we would have to fly new ones every time they flew. Does that answer your question, Gary? Barry, I'm sorry.
At this point, you're talking about the next decade before anything would be.
Well, no, I wouldn't say the next decade. You know, 2027 to 2030, I would say, is probably the time frame we're talking about. But let me just say this. There's opportunities right now. I know this. There's opportunities right now in Artemis 2. which is going up next year. But, you know, you got to have something ready to go. Yeah, and you don't have it right now. So this is the challenge. I mean,
The Lunar Gateway you're talking about in 2029, 20 plus.
I think 2028, 2029 is a good area for us to be working towards for Lunar Gateway. We're not going to be on right at the very beginning. We weren't right on the very beginning on shuttle either. So, you know, and it's going to, as time goes on, it's going to be more challenging. I'll also say another area where, which are opportunities, and we're looking at them very carefully, are the landers, the human landers. And for those that aren't familiar with it, the two major ones out there are the SpaceX Starship and Blue Origin's Blue Moon vehicle. And so those two have been selected by NASA as commercial organizations to support that. So those are opportunities we need to be looking at too. Any other questions? And I know I've already seen we got 4 minutes.
Maybe a dumb question, but couldn't the bird just listen to noise originating from Earth to decide when not to transmit in that exclusion zone on the far side? Kind of like the Apollo missions when they went to the dark side?
That's an idea. Yeah, that's an idea. But remember, if I go back to that shielded zone of the moon, it is before, well, it's the last third of the moon, okay?
Okay.
So, and you're not really behind the moon until, it depends on where your orbit is. You know, you're not
So
behind
you wouldn't be in radio shadow when you might be interfering with
Yeah,
the,
exactly.
And
Exactly.
also, do you happen to know if the Lagrange points would be satisfactory, like L4 and L5, which would they interfere with the far side exclusion zone?
Well, let me just say that the two main Lagrange points that the space agencies are looking at and commercial folks are looking at are L2 and L1. L1's on, of course, on the near side, and the L2's on the far side. The Lunar Gateway's in the L2 region, so that's another reason why we have to is no go. We did 2 meters and 70 centimeters are for contingency only. And like I said, 406 actually they're going to be transitioning search and rescue over from 406 to 2 gigs. Yes, Burns.
Yeah, so I'm wondering about the 70 centimeter stuff that you talked about being contingency ops and having to prove that it was a contingency. Do you only have to prove it was a contingency if you transmit in the restricted shielded zone, or would you have to do that anytime? I mean, you were talking about a repeater on the surface, for example.
Well, yeah, the repeater on the surface. Yeah, I understand what you're getting at, and that's exactly what Calvin was trying to bring up earlier. Is if you could figure out where you're at, then you could turn it on and turn it off.
Oh, so it is possible to use 70 centimeters as long as you're not in the...
It is possible,
Okay.
but you better have a foolproof system to
Got
be
it.
able to, and could be an issue. Yes. Go ahead.
Hey, yeah, Frank. I have a presentation this afternoon about non-AMSAT amateur satellites, and one of the ones I'm going to mention is Lunar Oscar 2 from the Harbin Institute of Technology, which is going to use 437 megahertz, and it's going to launch with the Cheney 6 mission next year. So, that's obviously it's not going to protect the shielded zone, but that's one upcoming mission where 70 centimeters will be used, and it will have a digipeater, just like the last one they did back a few years ago.
Yeah. So, and this is where we've got to be, and I think our spectrum, our satellite spectrum folks, I really would encourage you to specifically for the amateur radio satellites, work this and make sure that we don't have these kind of problems, because it'll give us a black eye, and I think you all know we're very close to losing 1.3 gigs because of the problems. So I'm not saying we are, but when it's at the level it is in the World Radio Conference, it's a concern. So we just need to be good stewards of the spectrum that's out there. Thank you.